So the first thing we want here is the difference scores. In this case, they tell us to take the new minus the old. And once we do that, we can drag that formula all the way across, and we have our difference scores. These are what we're actually conducting our test on. The first thing we want to do here is our t-statistic. Formula here is average of our difference scores divided by, and then I'm going to put parentheses here, the standard deviation, sample standard deviation of those scores, divided by the square root of n. N would just be the number of scores, so in this case that is, I'll close that out, and that gives me my t-statistic. So we get our t-statistic. Now notice that's not quite negative 1.431, and we have negative 0.1435. That's just a rounding error. If they would count something like that wrong, that's certainly something you would let me know, and I would give you full credit. And I would also submit a complaint to Hawks if that would be. All right, and here we do the t.test distribution, and it asks first for our x, which is just our and then degrees of freedom. So in a paired differences test, you're going to take the number of pairs minus 1. So we have 8 minus 1 gives us 7 degrees of freedom. And then the cumulative distributive function, we say yes, we want everything to the, and that gives us our p-value of 0.10972. Now, we're not quite done here. We have to ask ourselves if it's a one-tail or a two-tailed test. In this particular case, it said golf club manufacturer claims that they can lower their scores. Because it has that directional word, it is a one-tailed test, and so indeed we can just keep this. If it had said there's a difference in the scores, but it doesn't tell you what direction, this would be the area just in a single tail, and you would need to double that. But as it is, this is our final answer because it is a one-tailed test. We simply wanted to see if these new clubs would lower the golf score.